Video 11.3, Day 1, Independent and Dependent Events. Essential question. How do I find probability of independent and dependent events? Let's first talk about what does it mean to be independent or dependent. Events are independent if the occurrence of one does not affect the probability of the other. If a coin is tossed twice, it's landing heads up on the first toss and landing heads up on the second toss. They're independent. The outcome of one toss does not affect the outcome of heads on the other toss. To find the probability of tossing heads twice, multiply the individual probabilities. 1/2 times 1/2. The second probability is not adjusted based on the first because they are independent events. So the formula for finding the probability of independent events is you're multiplying the probability of the first event times the probability of the second event, just like tossing a coin twice. Example 1, we have a 6-sided cube. Now notice, that's not more than one cube, it's one. We have one cube. When we have 1 versus 2, it's gonna make a difference. It's labeled with numbers 1, 2, 2, 3, 3, and 3. 4 sides are colored red, one side is white, and one side is yellow. Find the probability. Tossing a 2, and then a 2 again. So this is not a normal 6-sided cube that has 1, 2, 3, 4, 5, 6. Here are the numbers on the 6 sides of the cube. So we're going to have the probability of tossing a 2 and then tossing a 2 again. These are independent events because I'm going to grab the cube and I'm going to roll it. The probability of getting a 2, well, there are 2 2s. So that would be, and there's six sides, or 6 different numbers, not different numbers, 6 different sides to the cube. So that is 2 over 6. Pick up the cube and I throw it again. What's the probability of getting a 2 again? That's still 2 over 6. That's 4 over 36, because when you multiply fractions, remember, it's not the same as adding fractions. You don't need a common denominator. You multiply the top, 2 times 2 is 4, and you multiply the bottom. 6 times 6 is 36, and we reduce it to 1 over 9. Now we're going to find the probability of tossing a red, then white, then yellow. So up here, we just tossed a 2, then a 2. 2 different probabilities. Now I'm going to have 3 different probabilities multiplied together. So let's go back up. 4 of the sides are red. 1 of the side is white. And 1 is yellow. Again, there are 6 sides. The denominator is still going to be 6, 6, and 6. How many reds are there? 4 of sides are red. So I have a 4 out of 6 chance of flipping the cube, not flipping, rolling the cube and it landing on a red side. Then I pick up the cube and roll it again. I have a 1 out of 6 chance of getting a white because there's only one side that is white. And I get a 1 out of 6 chance of getting a yellow because only one of the sides is yellow. 4 times 1 times 1 is 4. And 6 times 6 times 6 is 216. If I reduce that, 4 goes into 4 once and 4 goes into 216 54 times. That is the probability. Example 2. We're going to find the probability of A, rolling a 6 on one number cube and a 6 on another number cube. So this is not the same cube that we used in example 1. We're assuming here that this is a fair number cube, meaning that, oops, that did not work out. Let's try that again. Meaning there are 6 sides. 1, 2, 3, 4, 5. And 6. So we're going to find the probability of rolling a 6 on one number cube and then a 6 on another number cube. So it looks like we have 2 different cubes. We're not rolling them at the same time. We're rolling them separately. So there are 6 sides on a cube. There are 6 sides on the cube. How many 6s are on a fair number cube? 1. And again, 1. 1 times 1 is 1. 6 times 6 is 36. There's our answer. Again, these are independent events. The probability of the second event is not affected by the probability of the first event. Tossing heads, and then tails when tossing a coin 3 times. So 3 times. 1, 2, 3. You have 2 possibilities, heads or tails. So tossing a heads, there's only 1 head on a coin, then heads again, and then tails. 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. There is our probability. Now we're going to talk about dependent events. Events are dependent. Let's highlight this. Events are dependent if the occurrence of one effect, or if the occurrence of one event affects the probability of the other. Here is a great example to demonstrate that. Suppose that there are 2 lemons and 1 lime in a bag. Okay, so I'm going to write that. In this bag, oops, let's go back here. In this bag, we have 2 lemons and 1 lime. If you pull out 2 pieces of fruit, I don't know what I'm going to pull out of the bag because right now I have 3 pieces of fruit in that bag. The probabilities change depending on the outcome of the first. All right, so the probability of pulling out a lemon out of that bag, since there's 3 pieces of fruit, is 2 over 3. Probability of picking a lime is 1 over 3. All right, so let's say I pull out a lemon out of the bag. Then you're asked, well, what's the probability now of getting on a second pick a lemon again? Well, after picking a lemon the first time, we now go from 2 lemons and we only have 1 lemon left to pick from. And instead of 3 pieces of fruit in the bag, there are now only 2. So the probability of picking a lemon again is 1 over 2. So let's go back to this example again. If again, I pick a lemon out of the bag first, and then asked what's the probability of getting a lime, still 1 over 2. Let's see what happens when we pick a lime first. The probability of getting a lime is 1 over 3. There's 1 lime, there's 3 pieces of fruit. If then I ask, what's the probability of picking out a lemon? Well, if I take that lime out, there's only 2 pieces of fruit left in, and they're lemons. 2 over 2, that's 1. If I take out the only lime in the bag and say, what's the probability of getting a lime again? That is 0. This is demonstrating that on a dependent probability, the probability of the second event is affected by the first. What we're going to use is conditional probability. And here it is. Let's highlight this. All right. So the probability of A and B is the probability of the first event happening times the probability of the second event, given that the first event had already occurred. That's called conditional probability. Example 3, we're going to do in class, and example 4, we're going to do right now. Whenever you are given a problem that says 2 number cubes are rolled, that means rolled together at the same time. That is different than example back here, that said, right here, we're rolling a 6 on one cube and a 6 on another cube. We're rolling each cube separately. Here, 2 number cubes are rolled, one white and one yellow. We're going to talk about why the events are dependent, and then we're going to find the indicated probability. And the indicated probability is right here. I can find my pen. Go to my highlighter, and we'll call it green. The probability that the yellow cube shows an even number, and the sum is 5. Whenever 2 number cubes are rolled, you're going to want to create this table. It's not hard to create. Takes a little bit of time, but trust me, it's going to be helpful. Look how easy it is to create. I have a blue that isn't highlighted. 1, 2, 3, 4, 5, 6. All of them. There's 1, 2, 3, 4, 5, 6 columns. Then I have a 1, 1. All the ones are with the 1, 2, 3, 4, 5, 6. All the 2s, all the 3s, all the 4s, all the 5s, all the 6s. And that's how you set that up. So let's find the probability that the yellow cube shows an even number and the sum is 5. Okay, well, the yellow cube showing an even number. Well, let's see. Let's circle this. The yellow cube shows an even number. Well, that's going to be right here. And you circle them in pairs. They go together in pairs. Okay, just pause with me. All right. Here we go. The probability. Probability that we show an even number. Well, number 1, there are 36 different pairs. So if I count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, all the way, there are 36 different pairs. How many of those pairs show an even number? 6 plus 6 plus 6, that is 18. This is dependent. So now we talk about a conditional probability. Out of those 18, how many of them have a sum of 5? Well, let's look. 3 plus 2. Okay, 1 plus 4. I think only 2. As you can see, we get 2 over 36, which reduces to 1 over 18. It's conditional, or it's dependent, I should say, which we use a conditional probability, because the second probability is dependent on what I chose on the first probability. The yellow cube shows an even number. All I care about is everything that I circled in red, red, and red. That's what I use to find my second probability, not the ones that have an odd yellow cube. So I should write this is dependent. Okay. And pause the video, please, and do these video questions in your notes.